list, please report to the lobby. Juniors that are on the list that was forwarded out, please report to the lobby.
All right. So multiplying works differently than the adding, subtracting, and just multiplying by a number. When I ask you to multiply with matrices, what you actually end up doing is multiplying a row and a column together to get a single number. So if I ask you to multiply this row and this column, you are going to get one number for your answer. To do that,
-30.
that's
Take a
good.
wild guess.
Just wild guess.
3 times -5 times 2.
You actually start out, you multiply the corresponding numbers. So you do the first one in the row times the first one in the column. So we do 3 times 3.
Oh,
We do the second one times the second one. So we do -5 times 4. We do the third one times the third one. So we do 2 times -5. And then we add all of that together. So we get 9 plus -20 plus -10. So we get -21.
well, all I did was multiply the row, not the column.
That's how I got it.
Not row times column.
So it's not that the math is hard, but it's not as straightforward as just multiplying each corresponding number. You have to take the entire row times the entire column, and you get one answer.
I thought we were gonna like create it and do like the row 1, column 1 to be 9, and then go down
Oh,
across
yeah.
and make a square.
So we cannot multiply any two matrices together. It has to be specific. Just like when we were adding and subtracting, they had to be the same size in order to multiply, or in order to do that. With multiplying, the number of columns in the first must be the same as the number of rows in the second. So the number of columns in the first matrix must be the same as the number of rows in the second. FYI, I think this might be one of the Math Excel questions. It has the number of blank in the first must equal the number of blank in the second, in case you want to jot that down. So quick check, what we will do is we'll write the size of the matrix and the number of columns in the first has to be the number of rows in the second. So then you can multiply them. The size will be the outside two numbers. So when you take, for instance, if I said a 3x2 matrix times a 2x4 matrix, since these twos match, we can multiply them. Our answer would be a 3x4 matrix. And we'll do that on every problem we work through, just to kind of help make sense of it.
What is the M and the L?
Representing the size of your final. I did the same thing down here, just with numbers.
Oh.
Kind of explain it.
Oh, so they're just a variable. Okay.
Yes.
Okay. Why'd you stop the
Can you multiply a 2x3 matrix with a 3x5 matrix?
No.
Never.
Let's see. So 2x3 and a 3x5. In order to multiply them, the number of columns in the first has to equal the number of
Oh, yes.
rows in the second. So we can multiply them. The size of the final matrix,
Is it 2x5? I like that.
could I flip it around and do the 3x5 times the 2x3? Do the number of columns in the
No.
first equal the number of rows in the second? No. So unlike regular multiplication where order doesn't matter, with matrices it will. Okay, so the order will make a difference. We could not do it the other way here.
So would it be no solution consistent?
Okay, so now we're just going to practice these until you guys are confident with them. So I want to find A times B here. So first, we have to check to see if we even can multiply them together. To decide if you can, what I always tell people is just write down the size. What's the size of matrix A? What's the size of matrix B?
I'm just taking up half the table.
If these inside numbers match, then you can multiply them. So since we're doing A times B, we could do this. What size will my final answer be? So my final answer will have 2 rows and 4 columns. Is everyone with me so far?
Mm-hmm. But we have to solve it.
So now we're going to actually multiply them. You are welcome to do as much or as little of this on your calculator as you like. So when we go through, we take a row times a column. So if you think about this final matrix, this is row 1, column 1, right? So to get that, we take row 1 times column 1. So when you multiply, you take the 2 times 2 plus the 4 times 4 plus the -1 times -3. And you're welcome to put that in your calculator if that helps you keep track of things, or write it out, whatever works better for you. So we get 4 plus 16 plus 3. So my next number, this is still row 1, but this is column 2. What's wrong?
No, we're good. I'll figure
So
it
I did the 2 times the 2, the 4 times the 4, and the -1 times the 2.
out.
Alright, so we are saying next we need row 1, column 2. So you're still taking that row and we're going to do it times each column. So you take the first number, so 2 times 5 plus 4 times 8 plus -1 times 1. Everybody with me?
Yep.
So the next number, this is still row 1, but it's column 3. So I am going to take the first row times the third column. So I have 2 times 1, 4 times 0, -1 times -2. Last one, this is row 1, column 4. So, row 1 times column 4. So 2 times 4 plus 4 times 6 plus -1 times -1. And what do you get? So a little more time consuming than adding or subtracting, but is everybody understanding where these numbers come from? Okay. So we keep going. This is row 2, column 1. So we are taking now the second row times each column. So 5 times 2 plus 8 times 4 plus 0 times -3. So now this is row 2, column 2. So 5 times 5 plus 8 times 8 plus 0 times 1. we have row 2, column 3. So all these times the third column 1. So 5 times 1 plus 8 times 0 plus 0 times -2. You get 5. And the final, we have row 2, column 4 again. So 5 times 4 plus 8 times 6 plus 0 times -1. And so that is my final matrix. Mm-hmm.
That's all we're doing today?
That's all we're doing.
Let's
I
go.
got it.
Give me the math Excel, baby.
So we don't solve anything?
That's easy.
Nope, that is
Hello.
everything.
This one's easy.
All right. So we have to see if we can multiply them. So the first one is 2 by 3. Second one is,
3 by 2.
so can we multiply them? How big will the final answer be?
2 by 2.
So you can multiply them because those numbers are the same. The outside numbers tell you how big your final answer will be. Okay. Row 1, column 1. So if you take row 1 times column 1, you have 1 times 1, 2 times -1, and 3 times 2. Row 1, column 2. So 1 times 2, 2 times 0, and 3 times 4.
Well, it'll be cold when they go up
Row 2, column 1. So you have 0 times 1, -1 times -1, and 4 times 2. And the last one, row 2, column 2, so 0 times 2, -1 times 0, and 4 times 4. Alright, how are we doing with this?
Great.
I have more examples.
No.
Okay, could I have multiplied this one the other way around?
Yes.
Yes. How big would your answer have been? 3 by 3. Okay, couple things I need you guys to do. There is a Math Excel. Second thing is, if you are taking this class for college credit, MACC has course evaluations open that we're supposed to do this week. So it's basically your chance to give any feedback on me, and I know,
Great teacher,
your
make her
chance
a
for
professor.
revenge. You have to have your Canvas login to do that. So if you're taking other online classes, when you log into Canvas, it should pop up. And if you would just fill out that survey, I would appreciate it. If you don't know your login, let me know and I can get it for you.
It's in my email somewhere. 'Cause I know I actually put it in my